time, given these candidates, we have a target, and so these are the candidates. Our target is 8. We need to find all those combinations where out of these candidates to make up to 8. So if you take a look, 1 plus 1, 6, it's 8. 1 plus 2 plus 5, it's 8. And the solution set must not contain any duplicate combinations. So what that means is like 1 plus 1, 1, 6 and 1, 6, 1. They are considered to be duplicates, so we need to skip that. So each number in candidates are getting used only once in this combination. So let's solve this problem just like we solved other combinations type of problem where we use backtracking. Result new array list and call our backtrack method. We'll define it in a second, so we'll pass our result. There will be new array deck which will be holding all those current values. We'll pass our candidates, we'll pass our target, and we'll pass the starting point. And later, once we call this backtrack recursive function, we'll just return our result. And let's define our backtrack recursive call function. So list integer result. The other part is we are doing deck of integer, which will be the current. We'll pass our integer candidates. We'll pass our target. So for target, we can say remain because like we'll be subtracting it, and then our starting point. And this backtracking uses DFS, so this will be a recursive call. We need to define our base cases. So when remain is smaller than 0, we'll just return out of it. And if remain is equals to 0, that means we have found our combinations, and we just need to store it in our result and send a deep copy of it current, and then return. Else we will just go through our loop where it will be from starting point I smaller than candidates, because like we want to see all those things inside this candidates. Then what we are going to do here is important thing. We need to skip our duplicate. So the way we are going to do it, we will say if I not equals to start. What this means is that for this I, when we are calling out, let me write it down and then I'll come back for this explanation. And so another thing, so let's actually not address this yet, we'll address it in a second. So what else we need to do just to get any type of combinations, even 1, 6, 1 also included. From here we can just add to our current this given candidate, and recursively call our method send result current candidates. For remaining it, we can, because initially it was a target, so we'll just subtract this candidate because we have been subtracting it. And for starter, we can do plus 1. So another thing we could, so we are traveling, so we can, if we imagine this one as a tree, we are traveling from parent to child this way, and then from a child to parent we can just remove the last, and that's how we're doing the backtracking. And here we're taking the next candidate in our list, so not to reuse the same number. So every time in this backtracking gets called recursively, we are picking up the next number and next number, etc. So this is making sure that we are only using once this part right here. And another part where we need to address it, we need to not contain any duplicate combination. With this approach right now, it will contain. So how are we going to solve that? So we first of all need to sort it. Array sort this candidate. Now our array is sorted in order here. Next thing, when we are picking up here, we can skip if I not equals to our start point and candidates I equals to candidates I -1, then we can just say continue. What is this part doing? So we have sorted in order and we are saying I not equals to start. Why is that? So if we walk through our example right here, let's say it's like first time this method gets called, it's here, this will be false, this will be false. Then we are coming here, start point, we are seeing the length, then we are adding it to our current, then we are calling our backtracking, and this repeats again, this checks it, then this I becomes this start, then again this gets skipped, then we add it, and then it's like we call it again, and let's say that maybe it was smaller than 0, or let's say in this case like we are not adding it to our result, this gets not added, disregarded, and in case when it is 0, then it adds it and then returns it. So when it returns, it comes back to here, then we remove the last one, because like for whatever the combination we are using it, we add it here, or we didn't add it, we just skipped it, that combination, and then we're just returning it. So when we return it, then we're removing the last one from our current, because like we are looking for different combinations, maybe whether it was added or not, we're just removing it, and we're looking for different combinations. So when we remove it, we from child to parent, we just go from child to parent. If we imagine it as a tree, then this gets removed, and then once this gets removed, we start our next loop here, because like we are inside this loop, and I was previously for other start, and then this gets incremented, because like we are looking for the different combinations of this number in our candidates. So because like when we remove this one, we are still inside the loop, so we go and then we try to pick up the next candidate in our list. And in that case, start was previously called here, and whatever that number was here, now we are getting incremented basically. It's like we didn't increment here, we are here, now it gets to different, because like this was incremented here. Now I and start, they're not the same, so we are saying when they're not the same, meaning that we are choosing the next potential candidate when we removed from our current. If we can go with that candidate, we are saying for given candidate that we are looking at it, is that the same as the previous one? If so, then continue, because like this will produce the same type of combination that it has. It's just like in different order, and this array sort plays a big role in here. That's how we can make sure that the one we are picking it up, is it the same as the previous one? If yes, then it will produce the same combination. In that case, just continue. It gets continued, then we are in loop until it reaches to here, add it to a new option, new combination that we might see, and then it gets backtracked again, so etc. So let's run our code. Perfect, let's submit it.